Hey everyone, welcome to homework 3.1. I'm going to start by looking actually at this last page of classwork and go over it because it's the rules for exponents, and then we'll get into the actual homework for today, which just shouldn't take us that long. All right, so for this first one to simplify, remember that here we have like bases with the b, but the coefficients we also have to make sure we take care of. So the coefficients we are going to multiply by each other. So -4 times 2 is -8. And then we're going to multiply these together, and they have the same base, so we will add the exponent. So this will be b to the 8th power. So b is our best answer here. For number 2, it says simplify, and so we're going to do this again, dividing our coefficients. -9 divided by 3 is -3. And then we have a to the 5th divided by a squared, and so that will be a to the 3rd power. B to the 8th divided by b to the 4th. So remember that's the same as, oops, let me make that a little clearer, b to the 8th minus 4. So that will be b to the 4th power. Number 3 says simplify. Now here we have to remember our rules. So if you remember PEMDAS, hopefully you remember that, we start with the parentheses and then the exponents. And this is really an important part of exponents, that they are very early on in the scope of things. So we're going to start within the parentheses before we do this exponent here. So starting within the parentheses, -2a cubed times -a to the 4th power. Well, this is a -2 times a -1, so that becomes +2. And then we have a to the 3rd times a to the 4th. That will be a to the 7th squared times -6a squared. So now before I can do this multiplication, I'm going to need to do this exponent piece first. Remember, whatever is in the parentheses needs to have the exponent applied. So 2 squared is 4, and then a to the 7th power squared is going to be a to the 14th power. Then we will multiply times -6a squared. Again, we're going to multiply our coefficients first, and so we'll have 24. -24, and then here our bases are the same, so when we multiply them we will add the exponents, a to the 16th power. Our next one here, we have this exponent outside of our parentheses, so we need to apply that to everything in the parentheses. So that'll be -6 squared, which is +36, so 36. P squared to the 2nd power is p to the 4th power. And then q cubed to the 2nd power is q to the 6th power. Here we're going to simplify. Again, we're doing a squared. And here the base is the same, so we're going to subtract because it's division, so it'll be minus a -4. That one can seem tricky because 2 minus a -4 is actually going to be 2 plus 4. So that'll be a to the 6th power. And then b minus 7 minus a -2 will give us -7 plus 2, which would be b to the -5th power. So we'll then have a to the 6th power times b to the -5th power, but remember that a negative exponent puts this in the denominator, so then this would become b to the 5th power in the denominator. And so this one's a little bit unique because you have both multiple steps, positive and negative numbers, and then also one that has a negative exponent, so it's going to place that in the denominator. All right, so here again, we're going to start by multiplying our coefficients. -3 times -5 is +15. And then we have n to the -4 plus 7. Okay, because we're multiplying here, we're going to add our exponents because they have the same base of n. So we have 15 times n to the 3rd power. All right, I'm going to pause here. I want to remind you to make sure that you are listening to the audio here because I'm explaining it as I go. Don't just copy the answers. You don't learn from that. So make sure you are listening. All right, so we're going to start by first I would go ahead and make our denominator a little simpler. So I'm going to combine the denominator first. So we have 6x squared y to the 3rd power over. We're going to multiply our coefficients first. That's going to be +12. X to the 4th times x to the 3rd is going to be x to the 7th because we're adding those exponents. And then y to the 1st power times y to the 2nd power is y to the 3rd power. Well, now we have division. So 6 divided by 12 is going to be 1/2. We can make that 1/2 and reduce that. X squared minus x squared divided by x to the 7th is going to be x to the 2nd power minus 7. So that will be x to the negative 5th power. And then y to the 3rd power minus y, or divided by y to the 3rd power, is going to eliminate that essentially because it's going to be 1. Y to the 3rd power divided by y to the 3rd power is just 1. It would really be y to the 0th power, which we know is 1. So we're left with this. Now because we have a negative 5 here, that's going to take this x to the negative 5th and put it in the denominator. So it will look like this now. All right. This one, to simplify, you actually are going to calculate. So negative 2 times negative 2 times negative 2. Oh, and actually, no, I made a mistake. Because there is no parentheses around this negative 2, this is a negative, and then it's 2 times 2 times 2. Honestly, either way, and you'll come up with a negative 8 here. 8 times 8 is 64. 9 times 9 to the negative 1st power is 1 over 9. Remember, this puts this in the denominator. And then negative 4 to the negative 2nd power is 1 over negative 4 squared, or 1 over 16. This is in the parentheses, so that square applies to everything in the parentheses, including that negative sign. All right, number 9. Here, again, I'm going to start with what's in the parentheses first and then do the exponent because of PEMDAS, right, our order of operations. So negative 3 times 3 is negative 9. P to the negative 3rd times p to the positive 3rd would be p to the 0th power. So these are actually going to cancel out because that's going to be 1. Q to the 1st power times q to the negative 4th power will be q to the negative 3rd power. And that whole thing then is going to be squared. So here what I'm going to go ahead and do is do negative 9 squared first. Okay, negative 9 squared gives us 81. And then we have q to the negative 3, negative 3rd power, times 2 will be q to the negative 6th power. So this will become 81 over q to the 6th power. Okay, because that negative is going to put that in the denominator. All right, 5x to the 4th, we have to cube 5 first. So 5 times 5 times 5 will give you 125. And then x to the, because this exponent is outside the parentheses, x to the 12th power. Okay. Here, this one is honestly very tricky, so I'm going to go through this really the best that I can here first. We're going to start with this exponent here. So you're going to get negative 4a squared times, we're going to go ahead and move this whole thing to the denominator, times 2a to the negative 3rd to the positive 4th power now. Okay, so what's going to happen here is we're going to have a negative 4a squared. That's going to stay the same. Now I need to apply this power to this. So 2 to the 4th power is 2 times 2 times 2 times 2, which is 16. So that'll be 16. And then we will have a to the negative 12th power. So what's actually going to happen then is this negative 12 is going to go back up to the numerator. So we'll now have negative 4a squared times a to the 12th power all over 16. All right, now we're going to combine this top numerator part. Negative 4 times 1 is negative 4. A to the 2nd power times a to the 12th power is a to the 14th power, all over 16. And then what I can do is I can go ahead and I can reduce this because 4 over 16 is the same as 1/4. So this is negative 1/4 a to the 14th. And we can ignore that 1. So our best answer is negative a to the 14th over 4. Lastly, number 12, we're going to go ahead and start by dividing this coefficient. That's going to give us 2. And then we have x to the 5th power minus x to the negative 4th power. So this will become 2x to the 9th power. All right, as you're doing those, as long as you've listened and you have any questions, feel free to text me if there's something you still do not understand. A code word I want you to go ahead and write right here if you are listening is the code word, I don't know, moon. Put the word moon in there. And then we're going to go on to the actual homework portion of tonight. All right, so let's take a look here. Oop, too far. Which expression equals 2 to the 7th power? So 2 to the 7th means we're multiplying 2 7 times. So that is a multiplication piece. When we have exponents, it's repeated multiplication. It says evaluate the expression when x equals 2. That means we're substituting for x. So we have 3 times. This is order of operations. We have to do exponents first. So times 25, which gives us 75. The next one shows us a graph in investment amounts. And so it's showing us what happens over time with an investment. It says, what is the initial balance? Well, the initial balance would be at 0 years, so that's 1,000. And it says, is the account growing by the same number of dollars each year? Explain how you know. So after 1 year, it's gone up to just a little bit, right? It looks like a very small amount. But if you notice from year 11 to year 12, we suddenly have a big leap. So no, because the growth is greater at the end, right? Towards years 11, 12, it's starting to grow faster and the growth is going to be larger. It says a second investment account starts with $2,000 and grows by $150 each year. So we're going to start at $2,000 and grow by $150 each year. So if I'm going from $2,000 to $150 in year 1, so $2,150, and then I go up another $2,300, and then I'm going to go up to $3,500, or sorry, no, that's too much still. And a wise idea always is to create a table, so years and then money, dollars. All right, so we're starting with 2,000. Oh, no, put that in the wrong spot. Years is 0, 1, 2, 3. Right, so we're starting with 2,000. We're going up 150. So 2,150, 2,300, 2,450, for 2,600. 5 years, 2,750, right? And so then you would graph each of these points. So 3 is 2, 4, right underneath. 26 would be right above. 2,750. So notice that over time, what we're doing is creating a linear graph, okay? You can keep going, adding in your continuation of this here, okay? So it says we did that. How does the growth of balances in the two balances compare? So this would continue to go up, and in this case, the second account is a linear function, and it is growing at a constant rate. The first account is an exponential function because we see this curve and it's growing suddenly more quickly towards the end. All right, Jada rewrites this expression 5 times 3 to the x power is 15x. Do you agree with Jada that these are equivalent expressions? Explain your reasoning. So for questions like these, I would show an example. So if we do 5 times 3 to the third power, is that the same as 15 times 3? Well, here we would get 3 times 3 is 9 times 3 is 27. So 5 times 27 does not equal 45, right? So you can show this through putting in actual values for x that this will not work. Number 5 says investment account starts with a balance of 200 and doubles every year. Investment account 2 starts with 1,000 and increases by 100 each year. How long does it take for each account to double? So in investment account 1, takes 1 year. Investment account 2, in order for it to double, we would need to get to 2,000, right? In order for it to get to 2,000, we're going to take 10 more years, right? Because if we're getting $100 each year, it's going to take 10 years to get to that 1,000 mark. And so the second account takes, I don't know why the eraser function is only sometimes working. Takes, cross it out, 10 years. Okay. It says, how long does it take for each account to double again? So again, this would now take, for account 1, another year, because it's going to go from 200 to 400 to 800, right? And then the second account now, so it's gone from 1,000 to 2,000 in 10 years, right? So to get to 4,000, it would need to grow 20,000 more dollars. And so that's going to take 20 years. And then it says, how does the growth in these two accounts compare? Explain your reasoning. So you want to tell me, how does account 2 compare with account 1? So account 1 grows exponentially because it is doubling each year. And account 2 grows linearly at a constant rate each year. All right, number 6 says, a study of 100 recent high school graduates investigates a link between their childhood reading habits and achievement in high school. So participants are asked if they read books every night with another person when they were ages 2 to 5, as well as their grade average for all of their high school classes. The results are represented in the table. All right, so this is to show a correlation between reading and how well they do in school, right? What does the 21 in the table represent? So here, this is 21 students read nightly and earned a B. The 10 in the table says 10 students did not read and earned an A average. All right, number 7, Liz says, put a snack machine is like a function because it outputs an item for each code input. Explain why Lynn is correct. So if I put in a code, I only get one snack. So I can't put in a code and have 2 snacks come out, right? Only one comes out, so there's one output for every input. Number 8 says, at a gas station, a gallon of gasoline costs $3.50. The relationship between the dollar cost of gasoline and the gallons purchased can be described with a function. Identify the input, so this is review, input variable and output variable in the function. So it's the relationship between the dollar cost of gasoline and gallons purchased can be described as a function. So we can say cost is a function of gallons. And so then the input is gallons of gas. Output is the cost or the money. So we would say cost is a function of gas gallons, right? Which I just told you, so you can fill that in. Identify an input-output pair of the function, explain its meaning in the situation. So one input might be 1 gallon is $3.50. So you could say f of 1 equals $3.50. You could also say f of 2, if I buy 2 gallons, equals $7, right? Then you have both an input and an output. All right, your last and final code word is sun, like the object in the sky, spelled that way. If you have any questions, please reach out. Make sure to review in your notes, so go back into your notes and make sure to review your exponent rules. Again, you need to have these memorized, you need to know them, so make sure to study them. Happy homeworking and see you tomorrow.